Hello everyone, welcome to IMS Gate Academy. I hope you are doing great in your gate preparation, right? So only few months are left and this is the time you need to focus on the PYQs, okay? So that you will have a clear idea what questions gate will be asking, what are the standard of questions they will be asking. So the best way is to solve previous year question first of all, right? First, when you will have a confidence on the previous year question, then definitely you will be able to solve a difficult level problem also, or extra practice problems you can solve from IMS Gate Academy exercise books, right? So in this particular session, I will be starting a session of theory of machine previous year questions, first of all from Gate 2023. Last year previous year question we will be solving. While solving the question also, we'll be discussing the concept in detail, so that not only the solution you will be getting, also the concept you will be getting here. Okay, so please share the session with your friends and please try to attend this session and upcoming sessions also, because in upcoming sessions we'll be solving from other subject also like fluid mechanics. Okay, theory of machine is there already this year 23, next year we will solve 22, then 21, like that it will go, right? Okay, we'll start the session guys. First of all, the question from this particular topic, velocity analysis. This particular problem is from velocity analysis. Okay, now there are two methods to approach this kind of problem, because in velocity analysis we are having two methods, relative velocity method and angular velocity ratio method, in which, see what happens, first method we will be using velocity diagram. There is a set of rules that we need to use to draw velocity diagram. Second is what, eye center method, and the eye center method, the theorem that we are going to use is angular velocity ratio theorem. Okay, now I will be solving this question with angular velocity ratio theorem, because such type of problem become very easy with angular velocity ratio theorem. Within 2 lines you will be able to get the answer. Okay, now so guys, please focus on the diagram here and see what are the links in this particular mechanisms. You need to identify the links here. Okay, so see, first of all, what they have mentioned, wheel rolling without slipping, very important point. Wheel is rolling without any slipping here. Got it? On a horizontal plane with angular velocity omega 1. Okay, omega 1 is the angular velocity of the disc here, mentioned here. A rigid bar PQ is pinned to the wheel at P, at point P. This is your point P here. At this point P, it is pinned. Very important information. At point P, it is pinned or hinged. So it is kind of a turning pair. Remember this point. While the end Q is slides on the floor. So sliding is happening here. At this point, sliding is happening, and at this point, the rotation will be there because it is a turning pair. Okay, already mentioned pinned. Angular velocity of omega 2 with respect to angular velocity of simply omega 2 and angular velocity of the rod. There is a relation. So omega 2 and omega 1. Omega 2 is the angular velocity of the rod and omega 1 is the angular velocity of the disc. We need to identify the relation, right? Clear everyone? So that relation we need to identify. So as I told you, angular velocity ratio theorem I will apply here. So the very first step in that particular theorem is you need to identify or you need to locate the eye centers. You need to locate the eye centers, right? So first step here is location of eye centers. Okay, one by one I will locate the eye centers, and I hope you know about the theorem, one more theorem, Kennedy's theorem, which will be used to identify the location of eye center. And what actually that particular theorem will tell? According to Kennedy's theorem, if 3 bodies are in relative motion, all their eye centers will be in a straight line. Very important theorem. Okay, sometimes we are not able to identify or locate the eye centers. For that moment, you need to just see what is Kennedy's theorem. Whenever 3 bodies under motion, relative motion, their eye center will lie in a straight line. I hope this point is clear. Okay, now, so as omega 1 mentioned for disk, so I will keep disk as a link number 1. Second, omega 2 mentioned for bar PQ, so keep it as a link number 2. Third is a horizontal plane. Third is a horizontal plane. Clear? First of all, we have mentioned the names here. So there should not be any confusion regarding what I have mentioned, because I have mentioned 1 here because it is omega 1 they have mentioned simply. So our link number 1. Disk. Link to PQ. Rod. PQ. Link 3 is our horizontal plane. Clear? Is this point clear, everyone? So link I have mentioned. Next thing is what? Eye centers. Okay. First of all, eye center of a disk, because it is rolling here, eye center of a disk with respect to this horizontal plane will be this R point only, the point of contact. Very basic thing. So this eye center will become I13. So I will just mention that point here. So this R becomes I13. P point will be I12. P point will be I12. Now, the second thing, as Q point is sliding with respect to the third link, which is plane. As Q point is sliding with respect to horizontal plane, definitely eye center will be at infinity, because sliding is happening here. The question is, okay, that point is clear. Eye center of Q with respect to 3 will be at eye center. Done. But point is where it will lie. We told, okay, Q point is sliding with respect to horizontal plane. Perpendicular vertical line I will draw. Simply, I will draw a simple vertical line like this. But where it will be, I don't know. Now, under such situations, you again need to look for Kennedy's theorem. Just now I have told you. 3 bodies under relative motion, their eye centers will be in a straight line. 3 bodies like 1, 2, 3. What are the eye centers? I12. First eye center is I12. Okay, see. Another eye center is I13. Another eye center is I23. 3 bodies 1, 2, 3. So there are 3 eye centers, 1, 2, 1, 3 and 2, 3. 1, 3 I have mentioned, 1, 2 I have mentioned. What about 2, 3? It will be on a line joining these 2 points. When I am having 2 points, I can draw a line. Very basic thing. For drawing any one line, any straight line, you need what? 2 points. So already I am having 1, 3 and 1, 2. Using these points, I will draw one line. Now, so when I will draw one line here, definitely from this vertical line, this line is going to intersect, and that point will be I23. That point will be I23. So whenever you stuck in any moment where you need to find out the location of eye center, you always just think about the Kennedy's theorem. You will get the answer. Got it? Now, see. So we need to draw a line here. So we'll do it in the next page here. See. Simply I will draw the lines. Got it? So see, this is the point where it is intersecting. I've told you, this is the point where it is intersecting. So we have already mentioned this is I13, I12, right? So 2, 3 will be here. Clear? All the eye centers I have mentioned, 1, 3, 1, 2, 2, 3. Clear this point? Okay. Now, second thing is writing the ratio of angular velocity. Writing the ratio of angular velocity. Okay, and here actually maximum student will do the mistake. So we need to be very careful while writing the ratio of angular velocity. So what actually angular velocity ratio theorem will tell? The ratio of angular velocity of the links, that ratio. But how to write that ratio, that is very important here. Clear? See, so they're asking the relation between 1 and 2. So I will be writing like this simply. They're asking relation of 2 with respect to 1. So simply I will write omega 2 by omega 1. Now, link number 1 is your desk, link number 2 is your rod. So how to write this ratio? First of all, the common I center will come. Common I center will be I12. Very simple thing. Link 2 and 1, their common I center will be I12. Now, you need to take the distance of I12 from a I center of this denominator link. Denominator link is 1 and denominator link I center with respect to fixed. Fixed is what? Plane. So what it will be? It will be I13. Again, distance from the common I center 12. Distance from point I12 to that I center. Numerator first. Now in this case for denominator we will be writing for numerator link. Numerator link is what? 2. Numerator link I center with respect to fixed. So it becomes I23. Clear? Is this point clear, everyone? Okay. So always remember, like I will tell you the general case also, how to write this angular velocity ratio in any general case, right? For example, so we have this 4-bar link mechanism. Consider this as a 4-bar link mechanism. This is link 1, 2, 3, this is 4, right? Consider this as a 4-bar link mechanism. Just as an example, you need to understand. I want to write omega 4 by omega 2. Let's suppose omega 4 by omega 2 I want to write here. So common I center first of all is 2, 4. Now distance of this common I center from that I center of link which is there in the denominator, link number 2. So I center for link 2 with respect to fixed. Fixed is 1. So it will be I12. And similarly it will be I24 from 1, 4 like this. Again one more time. Let's suppose for 2 and 3 you want to write omega 2 by omega 3 you want to write. Common I center I23. Common I center is I23. Now distance from the common I center to that I center of link 3 with respect to fixed, that is I13. Common I center, distance of common I center from the I center, from that I center which is there here in the numerator, link number 2 with respect to fixed. Fixed is 1. So I12 will be coming. I hope you are getting the point here how to write the ratio of angular velocity. If this is clear, you can solve any problem of velocity analysis. And if you see the previous year questions, maximum numerical they have asked from this velocity analysis. And simply this method will be using, because from this method all the problems become very easy. All the problems become very easy if you use this approach. Got it? So I hope this concept is clear regarding angular velocity ratio. Now the point is how I will know this distance I12 to 13. What is 12? 12 is here, 13. So that distance is what we need to know. Then 12 to 23. 12 is here, 23 is here. Again, this ratios of distance we need to find. How to find that ratio of distance? Very important. So what I will do here, see. Let's suppose from this point, if I draw a horizontal line like this. Okay, consider this point as an x. Consider this as an X point. Now just focus on two triangles here. Focus on two triangles. Triangle OI12 and this 13. Triangle OI12 point and I13. So triangle formed by these 3 points. Please remember again, O, I12 and I13. These are the 3 points. So for that triangle, whatever the triangle you are having, using these 3 points, that triangle you need to focus. Another triangle, X, I12 and 23. Now, can I say both the triangles are similar? Yes or no? Simply tell me. How I can say similar? Because angle O12 and 13, O12 and 13 will be equals to X12 and 23. This angle and this angle will be equal, correct? So X12, 23, X12, 23, angles are same. Another angle, this is 90 degree and this is 90 degree. So 12X23, 12X23 is 90 degree, and here also, very important point, right? So what you will be writing here, 12O13, 12O13, again 90 degree. So two angles are similar here, 90 degree angles and this angle. So two angles are similar, automatically I can say both the triangles are similar in nature. Now this is a very important point, and you will see in most of the problems of velocity analysis, this concept will help us to find out the ratio for the distances. This similar property triangle. Whenever triangles get similar, we can write down the ratio of the distance, right? That ratio will be what used here in angular velocity ratio. If the distances are directly given, then there is no problem. But sometimes distances are not directly given. So in that case, we need to look for similar triangle. So this point you should remember. See what happens while doing preparation, we know the formula, we know the concept. But while solving the question, you will actually get to know how to implement those concepts. Execution part you know at that time. So approach implementation part will be clear when you solve multiple problems. But first PYQ you need to solve, then after that you can solve other practice problems. Got it? Okay. So we'll solve this problem here. Now we need what? 1, 2, 1, 3. 1, 2, 1, 3, okay, and 1, 2 and 2, 3, 1, 2 and 2, 3. This distance we need. Which distance? 1, 2, 1, 3 and 1, 2, 2, 3. Correct? This ratio. This distance ratio we need. So how to write this ratio? 1, 2, 1, 3 and 1, 2, 2, 3. How we can write down this distance? Tell me fast. Anyone? Any idea how to write this thing? Just think about it. Triangles are similar, no? One of the dimensions are given, like from O12, O12 we have a distance 2 meter, and in that triangle X12 we having a distance, what is that? 8 meter. So I can write this as O12, another as X12, which is 2 by 8, which is 2 by 8. O12 is 2 and X12 is what? 8. That is what we are having as a 2 by 8. Clear everyone? Very basic thing. Now this is given, then what you will do here? Directly use this value, because 1, 2, 1, 3, 1, 2, 2, 3, 2 by 8 I will put here. So let this equation as 1. Using equation 1, I will be having omega 2 by omega 1 as 2 by 8 as 1 by 4. Now 1 by 4 can be written as 0.25. Clear? So omega 2 equals to 0.25 multiplied by omega 1. Clear everyone? I hope this solution is clear to everyone. Any doubt or any confusion you can ask right now. Okay? Clear? So if you see the options here, Omega 2 is 0.25 of omega 1. Option D will be correct. Omega 2 is 0.25 of omega 1. Done. Now moving to the next problem, guys. The next problem is from the gates chapter. Again, very simple problem they have asked. Very simple problem. Just you need to know the basic terminologies of the gates. Like in the question they have mentioned this diametral pitch. You need to know what is diametral pitch. Okay. Angular velocity ratio they have given. They have provided mod here. So simply it means they are taking the magnitude only. Ratio of magnitude of angular velocity. They have not taken the direction into consideration. Centers are 30 mm apart. Center distance they have given. And what they are asking, number of teeth on the driver. And again I am telling you, this kind of problem earlier also they have asked. And this kind of problem is again very easy. I will tell you the basic concept behind such problems. See, in the gate, concepts will get repeated, not exact question. So if we have a good command over the concept and we have solved multiple questions from that particular concept, you will have confidence. See, gate is all about confidence. If you are having the confidence, you will be able to solve tough problem also in the gate examination. But for that, sufficient numerical practice is required. Okay, so that practice you need to do. It's not about just memorizing all the formulas. It will not help. Simply you need to do more practical approach you need to take. What is that? Solve more number of problems. Simple. Now, so one by one, I will take the given data what they have mentioned. Diametral pitch. Diametral pitch. What is diametral pitch? Simply it is T, number of teeth divided by diameter, which is given as 8. Now, what is module? Module is just reverse of that. Diameter divided by number of teeth. So 1 by 8 it will be there. And remember, module always expressed in mm. The angular velocity ratio. Next thing what they have mentioned, omega 2 by omega 1 as 1 by 4. Omega 2 by omega 1 as 1 by 4. Now, omega 2 by omega 1 can also be written as, from law of Gehring, d1 by d2, and d1 by d2 can be written as t1 by t2. So T1 by T2 is actually 1 by 4. So from that what we are getting, I can write T2, right? Remember as this point, T2 as 4 times of T1. This is the information we got. So what they have provided, omega 2 by omega 1 ratio. From that, what conclusion I can draw? T2 is 4 times of T1. So that much analysis we need to do. Okay. So that is what we have concluded. Now, center distance they have given. Now, how to utilize that data? See, center distance, simply, center distance is what? If I have to write center distance, so please observe, this is the radius R1, this is the radius R2, pitch circle diameters, right? So R1 and R2 they have mentioned. So R1 plus R2 will be the center distance. Yes or no? R1 and R2, if I add R1 and R2, you will be getting center distance. Now see, module, what I have mentioned, diameter divided by number of teeth. If I write, instead of diameter, twice of radius I can write. So radius formula actually you will be getting as module multiplied by number of teeth divided by 2. That is the formula you will be getting. This is the formula you will be getting. Radius can be written as module multiplied by number of teeth divided by 2. Now, this formula or this relation I will utilize here. So, as center distance is given as 30 mm apart, it can be written as m t1 by 2 and m t2 by 2. Simply, instead of R1, I can write MT1 by 2 and for R2, MT2 by 2. Now, module will be same because both the gates are intermeshing. So, I can take common out. M by 2, I will take outside. This is T1 plus T2. Module is what? 1 by 8. T1, I will keep T1 as it is because T1 they are asking. So, T2 is 4 T1. Just now we have concluded this point. From this analysis, T2 is 4 times of T1. Now, T1 plus 4 T1, 5 T1. Okay, finally, if you solve this one, answer you will be getting is 96. Okay, answer you will be getting is 96. Clear everyone? Basic problem they've asked, very basic problem. And this is not the first time they've asked. Earlier also they've asked this kind of problem. I hope this is clear. Now coming to the next problem, guys. Coming to the next problem. This is the problem from vibration. Okay, so again, just remember this point. Whenever center distance is given, R1 and R2. See, center distance is what? This is the gears 1 center, this is the gear 2 center. So when you will draw the pitch circle will be meeting at one point, that is pitch point. So this is R1, pitch circle radius of gear 1. This is the pitch circle radius of gear 2. So R1 and R2 are the pitch circle radius. You should not forget this point. Pitch circle radius. For gear 1. Pitch circle radius for gear 2 and for gear 1. I hope this is clear, everyone. Done? Okay, now moving to the next problem here. This vibration. Okay, again, very easy problem. Just you need to take care of some important things here. Because if you read this particular question, what actually they are asking in this question. Because sometimes we know the formula, we know everything, but still we do some small silly mistakes. And from that we are getting not 0, we are getting negative marks. So the point that you need to remember here is, if you are able to reduce your mistakes, automatically your marks in the GATE examination is going to increase. I hope you are getting the point. So try to minimize your mistakes. How you can do it? Simply give more number of mock tests. Full length test you need to give. More number of mock tests you are going to give, you will analyze that, okay, this in this area, this kind of mistakes I am doing, these are the different mistakes I am doing. You will work on those mistakes. You will try to improve. So obviously, multiple times you have given the practice mock test, obviously your mistakes are going to reduce. You will do less mistakes. So more practice will be required to understand what kind of mistakes you are actually doing. If I don't practice and at the GATE examination, I've not given any full length mock test before the GATE examination, definitely I will be doing many mistakes. So the purpose, the agenda of having this mock test or the full length test is what? So that you can have a practice, and while doing so practice, you will be able to know what are your strengths, what are your weakness. You will identify. Once you have identified, you will work on your weakness so that that weakness can also become your strength. Okay, so clarity should be there. From where you will get the clarity? Clarity will be given, will be there when simply you will give the mock test. It is just a feedback. Don't, like sometimes if anyone getting a less marks in the full length mock test, they will get demotivated. You should not get demotivated. It is just a feedback of how much performance you are having. See, there is a two different things. Preparation and performance, both are different things, and there is a gap between those things. Preparation is there and performance is there. There will be a gap. So when you will give more practice test or mock test you are giving, you will identify what is the gap and you will try to fill that gap. You need to fill that gap. And for that, whatever efforts will be required, you will do it. So that whatever preparation you are doing, approximately you will be getting your performance. You will perform according to your preparation. Otherwise, there will be always a gap between preparation part and performance part. You need to fill that gap. And for that, you need to give full length mock test. Okay, multiple mock tests you need to give. It will be just a feedback. Learn from the feedback. Whatever feedback you are having, do the analysis. Where you are doing mistakes, what are your weaknesses, work on those areas. And definitely you will improve and your marks will also improve. And finally, you will get the success in the GATE examination. That is what the purpose and objective of having mock test. Right. Now, going back to the problem here, GATE 2023, 2 marks problem they've asked from vibration. This time vibration question was very easy. Okay, compared to previous problems of the vibration, if you see, this is very easy. But still, in this problem also some students have done mistakes, I know. Okay, so first of all, we'll read the question here. So there is a, first of all, in the diagram they have mentioned there is a mass here. This is the two springs connected in parallel. So what it shows, figure shows a block of mass 20 kg. Okay, attached to a pair of identical linear springs. Identical springs are there having a spring constant 1000 Newton per meter. Remember, unit is given as Newton per meter. If Newton per meter is not given, like Newton per mm, Newton per centimeter, like that they've given, we need to change it, because the unit is what? Newton per meter as a SI unit. And most of the time we are doing a SI unit mistakes. Unit mistakes we are going to do while solving the problems. So unit we need to take care. Various very serious consideration you need to give on the units. Very important point. Okay. The block oscillates on a frictionless. Okay, frictionless they have mentioned, so obviously damping is not there. Assuming free vibration, time taken by the block to complete 10 oscillation. So obviously if I give little bit disturbance if I provide it, it will try to oscillate like this. Now what is the question? Question is how much time it will take to have 10 oscillation. First of all, calculate in one oscillation how much time it will be having. Then accordingly I can calculate for 10 cycle also. Not for 10, any number of cycles I can calculate. But first of all, in one cycle how much time will be required, that is the first thing you need to understand. Okay. Now this is the system it is given. Okay, we'll solve this one. So first I will write the data here itself. See, data is they have mentioned K as 1000 Newton per meter, mass is 20 kg, and what they have mentioned simply stiffness. Okay, springs are in parallel. Now they have mentioned take pi value is 3.14. No issue, we'll take that. Now for this free vibration, if you want to calculate the natural frequency omega n, how you will calculate? There is a simple formula, under root K by M. Unit is what? Radian per second. Now in this formula, very important point that you need to understand is whenever omega n is there, we are calculating using formula under root K by M. Radian per second. Using this formula, if I am calculating the natural frequency of vibration, first thing that you need to understand, K should be in Newton per meter. This is the unit you need to take care, and mass is in kg. If you have done the mistake in this units, you will be getting wrong answer. Sometimes what we'll do, we'll remember the formula, but we are not giving so much attention on the units. Units are very important. Please try to understand this point. Units are very important. So we need to understand while using this formula, K should be in Newton per meter, mass should be in kg. And sometimes, okay, they will mention kilonewton per meter. So let's suppose if K value is given as 5 kilonewton per meter. So what students will do generally, they will directly put what? 5 only. That is what wrong. Hi Mithun, a very good evening. So directly they will give what? 5 kilonewton, they will be giving the stiffness, and generally most of the students, the mistake they are going to do, they will put 5 as it is. That is wrong, because the unit is Newton per meter. So I need to write for 5 kilonewton per meter. What should I write? I should write 5000 Newton per meter. I hope this is clear. Now K, one more thing that you need to understand. Whenever you are writing the formulas now, at that time you need to understand this K is what? Equivalent stiffness. This is what? Equivalent stiffness. So as in the problem we have two springs in parallel. Two springs in parallel we are having, so equivalent stiffness we need to calculate. So if you want to calculate the equivalent stiffness, see, for parallel case, simply what I will do, I will add both the stiffness. As both are having same stiffness, K plus K will be 2K. Okay, so already K value is 1000. So after adding both the values, we will be having 2000 per meter. So equivalent stiffness we got. Equivalent stiffness we got 2000 Newton per meter. Done, everyone? Okay. So I will put the values here. Equivalent stiffness value 2000, and what is the mass we are having? 20 kg. Okay. So this 0 will get cancelled out. It will be 100. So omega n answer is what? 10 radian per second. Got it? This is what 10 radian per second is the natural frequency. Very basic thing. Now, as in the question they are asking, how much time will be required to complete 10 oscillation? So what I told you initially, first understand how much time it will take for one oscillation. So from where I will be able to understand how much time it will take for one oscillation? What is the parameter that I need to use here? Which parameter I need to use? See, frequency can also be expressed as hertz, and what hertz basically means? Number of cycles per unit time. Number of cycles per unit time. Okay, that is also a way of calculating frequency, which is represented by Fn, which is nothing but omega n divided by 2 pi. Omega n by 2 pi. Clear? Unit is hertz. Hertz represented as cycles per second. How many cycles it will have? Cycle of oscillation. Cycle is nothing but oscillation only. Number of oscillations per second. In 1 second, how many oscillations it will be having? Okay. Now, omega n already we have calculated. 10 divided by 2 pi. You can calculate, you will be having some value. Okay. Do the calculation. I have already calculated that value. Okay. It is 1.5915 cycles per second. Now, what does it mean? It means 1.5915 cycle, or basically oscillation, it is doing in 1 second. Got it? Now, in 1 cycle, how much time it will take? For 1 cycle, it is taking 1 second, right? For this much cycles, 1 second it is taking. For 1 cycle, how much time it will take? 1 divided by 1.5915 second. Next, I need for 10 cycles or 10 oscillations. 10 divided by 1.5915 second. Clear? This much second will be required for 10 cycle of, or 10 cycle or 10 oscillations. You can say anything. Now, if you solve it, answer, what will be the answer? If anyone has solved, answer will be approximately, it is coming as 6.28. Okay, 6.28 will be the answer you will be getting here. 6.28 second you will be getting as an answer. Clear? Very basic problem, but still you need to know. If they are asking about the cycle or oscillation, I will get to know from this particular relation, Fn, omega n divided by 2 pi, because the unit is what? Hertz. Hertz is number of cycles per unit time. So we got the value of Fn as 1.5915. So 1.5915 is the number of oscillations in 1 second. Cycle basically means oscillation only here. So that many cycles will be done in 1 second. I want to have 10 cycles. So, but for that, I will calculate 1 cycle time. Then I can easily calculate 10 cycle time also. Aptitude, basic aptitude. Clear everyone? Is this part clear? Very basic thing they have asked. So, guys, again, very important here, you need to understand how the previous year questions they are asking. That's why you should be having the full confidence in the previous year question. It's not all about like simply solving the previous year question. You should know what actually they are asking in the solution part, which approach you have used, which formula you have used, what is the trick that you have used. All things should be clear in your mind. So once you are fully confident in the PYQ, then you should move for other practice problems. For that, you are having your practice books, exercise books, you can use that. Okay, and also other practice questions you will be getting from where? From the online test series. That's why giving online test is very, very important in GATE preparation specifically. Multiple tests you will give, multiple type of variety of questions you will be getting, and more practice you will be having, and you will have a good command over every concept, every subject. Because if you solve more problems, obviously your command over the concept will get increased only. So most of the time student will think, okay, I will remember the formula and I will do the numerical also. That will not be possible. Even if you know the formula, you will not get the correct answer, because the approach part is what missing, and approach you will not get in one time. For that you need to struggle. Struggle basically means you need to solve the question on your own first of all. Think about how to solve this question, which approach I need to use. So that struggle part you need to do. Then the learning will be there. Got it? And one more thing guys, you should understand here, like while giving the GATE examination, sometime question comes which is like totally new for you, and you don't get any idea how to approach that problem. So better skip that problem for the moment, and later you can again come back to that problem and solve it, try to solve it. But initially don't attempt any new problem for which you don't have any idea. You don't have any approach how to solve that problem. You should not attempt those questions. You should basically skip, and in the last moment and whenever time you are having, in that moment you can again come back to those questions and apply whatever you know. Maybe you will get the answer also. Right, that is also possible. But initially I should not be wasting time in solving those questions which I have never solved, and also I don't know the approach, but still for the sake of doing, I'm doing. Time waste should not be there. We should not waste the time. Time management is very important. Accuracy and the time. Speed and accuracy are the two basic parameters. Okay, two important parameters that you need to understand. Because if any of the parameters you are not handling properly, you will not get a good score. Okay, if your speed is high but accuracy is not good, you will not get good marks. Accuracy is high but taking so much time, you will not able to solve all the questions. Ultimately, less score you will be having. Are you able to understand this point? So these are the small things that you need to understand. In the GATE examination, it's not all about the concepts you know. How you implement those concepts, how you apply those concepts, what is the execution level. Execution part is what very important here. So this point you should remember, those guys who are getting good rank, it's simply because they have done more practice as compared to you. It doesn't mean that they are having so much concept in detail they are having. They are not having like good concept, or they are not like talented. Talented basically means they have done more practice simply. Concept wise, everyone knows the concept, guys. Very basic thing I'm telling you. Everyone knows the concept, everyone knows the formula also, but some are getting answers, some are not getting answers. Simple point. So you should ask yourself why it is happening. Because you have not solved the problems. Just you have understood the concept and just you know the formula. But where is the implementation part? Where is the execution part? Have you done anything for that? If you have not done for that, you have not done anything for that, so simply you can't expect in the GATE examination you will be able to solve problem. That is totally not possible at all. So simply try to solve as many as problem, try to give as many as tests possible, and do multiple revisions. So giving the test is the best way to revise any subject or any syllabus. Full length test if you give, multiple revisions will automatically done. Got it? So in this session, we have solved all the problems from GATE 2023. Next session again I will take, in which GATE 2022 problems I will be solving, and again concept also I will be discussing, like the quotient simple velocity analysis, simple mechanism. There is a topic velocity analysis that I have taken, the first problem, GATE 2023. In that angular velocity ratio, how to apply that theorem I have discussed. So in the same way, in GATE 2022, all the questions I will be discussing in detail with the concept clarity. I hope you have enjoyed the lecture, and if you have enjoyed the lecture, please share this session with your friends so that they will also get benefited. And please stay tuned to the IMS GATE Academy YouTube channel. Multiple things are coming for you, and we will try as much as possible to help you in your GATE preparation. Thank you so much, guys. Thank you so much.